Okay, today's video is on the board here. Let me get up and start doing it. But I have to come with the model first, also install, and then we can do it properly. But it's already here on the screen. So basically, I'm gonna do it on the board. I've got my notes in here, so let me just get to the board and do it. Yeah, I'm gonna do it. Three colorful graphs. Number three colorful graphs. Or semantic graph, three columns semantic graphs. We're gonna have basically semantics. We have today's date is basically 26th of 6th of February 2016. The time now is 10:15 a.m. So this is the I've got a model here, but this is the CISCO model. So this is the three colorful stripe three colors of graph. Now, three color graphs are graphs that have three colors. They have three colors. They are tripartite. So it's a tripartite ruling system for engines. So I'm going to try to work on a complex sentence. Yeah, so this is find the property. So we're going to have a compound sentence. So you're going to have a compound sentence. Now, compound sentences have one to common to the top. P. So this is so basically we're gonna have a three column graph, three-way colorless semantic graph. What does this mean? So we're gonna have a graph. A graph is basically a directed acyclic graph, because directed acyclic graph, we're gonna have that for natural language. So we're gonna have the natural language here. So in this sentence, three interpretations on the system as opposed to one kind of code interpretation. One I'm really close to your interpretation. You have 3-to-1 mapping of interpretation. You have everybody have this mapping. So what's the goal of this mapping? The goal of this is to have a system of colorful graphs that resolve over three rules. So three interdependent DAGs. You can call them interpretation here. You're gonna have three interpretations. Three interpretations to one kind of thing more powerful. 3-to-1 mapping. Three states to one three states, three data to one mapping. So three states. So what does it mean? So you're gonna have a probing function P defined as given S. Now S is the state. S is the state of the program. D is the data. And P is the probe. So pre colon F given X implies D. So for every one probe, there's three states, three final states, S1, S1 to 3 implies three data. So for every situation, there's three data of unit 7. But that's the message. So what's the message system? So essentially we're gonna do today at 3 p.m. I will be heading out. So let's look at common sense. The common sentence has two independent clauses and one dependent clause. So that's complex sentence. A complex sentence has two independent clauses and one dependent clause. Which one means you're gonna have a complex sentence first. Well, I made this model. You're gonna have two independent clauses, and one dependent clause. But I'm gonna try to do it now. So you're gonna have it here. So let me start with the complex sentence first. This is what I made, guys. So complex sentence is gonna have today two independent sentences. At 3 p.m. Before 3 p.m. Okay, let me start. I built it the initial one at CISCO. Today I built it initial one at CISCO. Today at 3, I'm heading to I will be at Nationwide at 3:30 and CISCO at 4 p.m. I'll be at nationwide at 3:15 p.m. 3:50 p.m. at CISCO at 3:30 p.m. So let me try to understand this formally. I will be, this is the hardest one to do. I want to do a compound sentence, but this is a complex sentence. I'll be at, start running now. I'll be at, CISCO. I'll be at nationwide at 3:15. At CISCO at 3:30 to independence. Oh, two dependents. Oh yeah, two dependents. So sorry. Two dependents. And I'm back. Two dependents. So really, it's two dependents, one independent. Two dependents, one. It's two dependents, one. So I'll be at CISCO at 3:15 p.m. No, I'll be at nationwide at 3:15 p.m. at CISCO at 3:30 p.m. and back, and then I'll just go back and back on the road, and back on the road at for 3:30. During the different time from three was it 5 p.m. So this is the reason I will be so basically this is one sentence, one complex sentence. We're gonna do a comparison. It has two dependent clauses and one independent clause. So basically, I will be back at nationwide at 3:15 p.m. One independent clause. It's gonna be a full sentence by itself. Now, this full sentence is basically plural by one block, but it's the hardest one ever. So you're gonna have the one two. You're gonna have two one independent clause and two dependent clauses. This is the new independent clause. One independent clause. You give it a full sentence. You make a full sentence. So I will be back at nationwide. I will be at nationwide Building Society at 3:15 p.m. CISCO at 3:30 p.m. Now, CISCO at 3:30 p.m. It's not the full sentence. It doesn't. It's not a full sentence. It's gonna be CISCO. It's not. This is at CISCO at 3 p.m. But you can't start this can be at CISCO at 3:30 p.m. Now, at CISCO at 3:30 p.m. I will be at nationwide at 3:15 p.m. But this is not how you flip it. It's three column block. It's a complex sentence. It's complex sentence. You have one more sentence here. And this condition and projection, and I will be on the road at 4:45 p.m. I'm back on the road and back on the road at 4:45 p.m. Because because back on the road, what happens? What happens next? It doesn't give us full picture of what's happening there. So you can't paint a picture. You can't paint the kind of lesson. You just fall into two contexts. Two contexts. And you can have a less good criticality. You have business system model lifestyle and the powers of now. Very important standards, guys, with this model here. This is the quality interpretation. So you're gonna have two lexical two colorful lexicons here in this graph here. So because they have two dependent sentences. So they will not reach the semanticity of the parser. According to don't reach the semanticity of the parser because they are two dependent sentences, and they depend on the meaning. And the meaning will offer interpretation to the system. So this interpreter, so the two color boxes here, I guess I will be back at Nationwide. I'll be at Nationwide at 3:50 p.m. At CISCO at 3:30 p.m. now. These are two. This person is dependent, independent. And second two are dependent. So they fall into lexical system. They have interpretation. They go into system. They can be interpreted until there's a ability. They have a lexical. Can they have a lexicon? You have a lexicon. You have a lexicon, and you have a lexicon. So you have two lexicons, which are called interpretations. Two kind of called lexicons. CISCO lexicon, because CISCO is the bottom-up system that studies terms. So you're gonna have them all there. So this is the symbolic interpreter engine, and you have one parser, one medium. Now, one parser will be choose one method of the parser. Now, to understand what to say about constitution, I used to about the lexical state, you about the parser state. Now, the part of the middle of this will be I'll be back. The part will be the meaning. So if that's to do with the tokens have two sets of colorful tokens, two sets of color, two bypasses. So you have the bypass solution. So you have two bypass solution. You have a two tripart model. You have the trident ruling. So trident ruling, what's the meaning of this system? What's the saying? What's the meaning of this system? Yeah. So I'm gonna read the board here. But basically the pro shows P given S as well as space. Implies the data. Now, data is basically the lexicon, lexicon, and the two colorful graphs. The meaning behind the lexicon, the part is one semantic meaning. A semantic meaning shows there's no semantic drift. Because the lexicon, this is not going down, or let's look in the context. So, are we dealing with the right side stage or with the parser? Can the computer understand or not? This is what AS ontological, Bayesian, sorry guys, ontological Bayesian, like the Bayesian network, probability, intelligence, architecture, as infrastructure. So that's the foundation of this here. So basically, the foundation is basically ontological. System knows what it's talking about, knows what it's doing. It's going to probably ask the whole question. Because the data is internal representation of the system. The probe has the state, and data is the probe external is defined as the data. The data it outcomes given implies the state. So basically, it's bi-directional. It's a unilateral system because the probe can depend on the data, and the data can depend on the state. But if the data is the track you're giving them, if the stored probe, the stored input, the probe is going to give you new information. This new information, the data you're giving them, and that's the important state that really knows to resolve. So it's basically unilateral means that it works. It doesn't need consensus. It just gets on with it. It doesn't need you to act. I think you feed that data. You know what it's doing. You know what it's doing. And it's going to vote that way. Why does it matter this field? Ontological, Bayesian, intelligence. Listen, ontology just means system, me, myself, and I. The triangle rule is fashion. I know myself. I know what I'm gonna do. I know I'm gonna act. I observe and act. I know what I've done. I the computer. I the AI system know I've done. I the human I know what I've done. I the robots I've done know I've done. Ontology, me, myself, and I. But my frame of reference to the world. Bayesian means probabilistic guide. Probabilistic Bayesian network, probabilistic guaranteed stacking graph, which basically have probability of systems of like smoking and smoking. How much I smoke to get cancer? How much the work does smoke to get cancer? Well, it's basically demographic balance systems. because they work on kind of glyph. So the glyphs are symbols are glyphs when they're dynamic. So this this was distributed. This was like seven AI systems in Nigeria built from building. But I'm building AI symbolic interpreters now. Now these symbolic interpreters ensure that they work for people like us that are black in Nigeria. They work on our demographic data. They built around us. That's why ontology matters. So the AI system must help us, care for us until forever. There's no absolute point of failure because it's built around our qualia, our state of being, our way, not just import and export. So good ontological Bayesian intelligence. Now, intelligence means AI intelligence. But this intelligence is what I call symbolic interpreters. Symbolic interpreters. When they know what they do, they understand different between a glyph, which is like a glyph, which is E-I-O-U, but with taps, with accent, and tap. No, what's up? But because they have the system, know what a glyph is, and the glyphs are symbols that are diacritic. They work on the kind of diaphragm, and the nature of tonal presentation, representation of systems of like the essay, like what my famous essay if echo, as it says if echo is king. If it's height, low to height, Z is king, and low to height, low to the is teeth. But that's the two words I said, because that's the meaning. So it's in Igbo. So basically works with kind of glyph rotation. So I'll give you the model now. That's how it works. So that's my symbol. They are symbolic interpreters. That means to work with symbols. The ambiguity of symbols, like when you have many languages, instability. Basically, if you go to the NLM framework, I'm gonna give you the LM framework. I'm gonna give you the LM framework, the simple language model framework next. So let me drop the stop off and then get on with the NLM framework. So the sentence is there. I've noted it down here, but let me drop this out here. So how does it all work? So how this works? So because I'm just gonna work by this. You're gonna have fictional access to factual, formal, informal language to formal language to formal language. I'm gonna have a static language to a dynamic language. So this is the distributed language model, and this works. So distributed language is coherence over three axes. So you're gonna have an x-axis, more x, one axis. Is the system fictional or is it factual? Did you make the data up? You say it's fictional data. No, it's data. And this was the NSIGII protocol for. The NSIGII protocol is a human rights protocol. A human rights protocol for giving freedom. It gives you understand the beauty of language. So this thing will evolve. So basically, language evolves. This can ensure that language evolves over time. Language evolves over time. Based on the demographic data, the more you are, language evolves. The more you feel, the more it evolves. The more it knows about how language is structured in your framework. In the framework that is defined, in the demographic that is defined for. Igbo, based on Igbo philosophy, based on Igbo. So you're gonna have fictional. Now, fictional language, like you made it up, like Harry Potter, like the language thing that Harry Potter, it's just but it's still a language, yes. That language, the not percent, there's depth. So you have fictional language here. You're gonna have factual. Now, factual is like facts and figures and data, quantifiable language. Now, this is me language that basically means that it has some of a meaning to the word going on. It's all about data and figures and statistics and demographic data and us about us and cancer and diagnosis. Very important to have factual layers to be listening to all at once. But if you want to ace those stories, you have fictional language. And this one is there. These are too tolerable. So bypass order, by order and by key as well. Because there's two sides to the code. Am I classifying this as it's a homogeneous model to classify data as either fractional or fictional, like real data in fractional based on whether it has encountered it before, and whether it's encountered it before. But you should get right, and that's the more you get right, the more better. But it's the most question of the state, question of P given as FT, EST given D implies F means think of can also ask the computer what the data was, what the state was. But as soon as the computer is going to that state, there's an emotion it does. There's something is working towards it. It's basically knowing what you're doing. Because as soon as the data is in that state, in one state, it knows what you're doing. And you get fraction to fiction in formal data, in formal presentation of the relation of data on the data part to formality and formal, like the mathematical figures it's still formal, it's just giving you like historical and you can understand them, or it's giving you like layman's terms, or it's giving you informal linguistic terms or formal mathematical terms. Based on the parts of it, based on what it passed. And that's what I'm saying. What's the meaning of the language? What's the meaning? Is it formal or informal? To give you this, what's the representation? What's the state? What's the data you have for them? And what's the static? Now, static dynamic implies that the English is static language. If the language is rigid, it's not rigid from it's so rigid. But if the language is going to neglect, it's Tonio. This will we are. Tonio language. So if it's static, it's like English static alphabet, English alphabet. No language, no grammar to spam, no expansive grammar, which is basically called no language, no grammar to spam. And it's not that so just check if that's done, I'm done. But if it's in China, just do more probes, like three probes. Yes, 3 probes in the sentence. Yes, no, and maybe. So this one starts with grammar stuff. So how this works mathematically? Mathematically, this is defined as, let me put it here, as I will be back at CISCO at 3:15 p.m. I'll be nationwide at 3:15 p.m. I'll be nationwide at 3:15 p.m. at CISCO at 3:30 p.m. and back to the world at 3:25 p.m. But how this works? So basically, you have three colors. Let's say the colors are orange, green, and purple. Orange, green, and purple. But they have to fit into fictional and factual. So orange. Okay, let's say red, orange, and green. Red, orange, and green. Red, orange, and green. So red. So the red color will be basically. Red would be red, orange. Red, which is fictional and factual. If it's fictional, it will output to red. If it's factual, it will output green. If it's in between, it will output yellow for certainties. Yellow. Now, yellow for uncertainty, and this does thing. So, what's the one? If it's basically formal, you'll output 3 more colors, 3 colors. So there'll be a total of 9 colors. So I know this is defined properly. But the reason I'm writing so red, green, blue, red, yellow, and green for fictional factual. Let me sit down now, guys. I'm trying to do it properly. Let me try this properly here. So red, orange, and yellow. I've got my pen, have I? No, I've got my pen. Yeah, I've got my pen here. So, the CISCO model is execution orders. So, execution orders mean no other work here. Yeah, let me put it back here. I need a new card, guys. So, this is all formalizable. I'm sure, but how the system, so how does you're gonna have 3 columns. You're gonna have 3 columns. You're gonna have B squared minus 4AC. Now, B square of the first is going to changing a changing a state. So a state is given X. I can't remember how to do this with my pen's run out of ink, guys. I feel like I'm gonna abandon this video. Change change in changing changing a pole. So again, changing pole fictional. So basically, you're gonna have three probes. So you're gonna have I don't know. So basically, you're gonna have three glass. You're gonna have three glass. You're gonna have three dark. You're gonna have fictional, factual, informal, formal, static, dynamic resolution. Then you're gonna have three poles. You're gonna have you're gonna have three colors. You're gonna have three colors. For the graph, for the graph that handles fiction and factual, there's an informal. This called the CBD language model. So if you go to GitHub.com/OBNexus, O for Oscar, B for Bravo, I for Indigo, N for November, E for Echo, F for Short, X for X-ray, U for Umbrella, S for Sarah, /NLM, N for November, underscore, N for November, F for Lima, N for Mike, underscore framework, NLM underscore framework. You find the civil language frameworks. Because you're watching this, they look at the axis of this. So any kind of future thing is dynamics. So any kind of language evolution is dynamics. So this one made so far, So the goal is to have the kind of thing, the trends, model the dynamic nature of the system and reduce the problem. If the problem is reducible into so if you have you have B squared minus 4AC. Which give you a consensus of the power -1. You're gonna have the system it's a three-way colorable graph that over interpretation, and this is a system that's really ontological. It knows what it's doing. Am I done? So 7 minutes. So the goal is to have the probing system probe P given F implies D. P external given D. So the external input you give it implies the state. So this is what I'm saying to you guys. So it works like this. So this is how it works. So you're gonna have three ways. You're just gonna have fictional, factual, and you're gonna have a lattice alignment. So you're gonna have things that are you're gonna have a KNN cluster. And K nearest neighbor. So you're gonna have a cluster. You're gonna have a KNN cluster. Which you're gonna have a nearest neighbor analysis, and you have a cluster. So basically, you're gonna work on KNN cluster. So you're gonna have N. If you have a nearest neighbor, N nearest neighbor, you have a mini cluster. You have a cluster now. NK there's a disjoint cluster. There's two sets of clusters. So to the N you have one cluster, and N cluster, N nearest neighbor is the algorithm. Yeah. Basically, you're gonna have graph nearest neighbor clustering. But K makes it bipartite. So bipartite, you have a tripartite K clustering. So that's how it works. You're gonna have three clustering that you can color, three KNN clusters, for the terms you can color, and that's how that works. So you're gonna have a KNN cluster of the system. Now, how does this work? So you're gonna have for fictional and factual, formal, and dynamic. You're gonna have three set of colors, three colors for each system. So fictional is gonna have colors. So you're gonna have fictional have red, yellow, and green. Red, yellow, and green. So you're gonna have two sets. So you're gonna have two pairs of colors. They are green yellow. So you're gonna have red, yellow and green. So function. But they share one color. You got to have them one color. So you're gonna have a color of orange. So if they share orange, you have the orange in the middle. So you're gonna have red, orange, and green. For fictional to factual. Informal to formal, you're gonna have gray. Informal to factual, which is like informal minus the informal. You're gonna have gray and formal Okay, so you're gonna have light gray, informal, gray, formal, medium, and dark gray, formal, dark gray. Now, dark gray is literally gray, so you have a tint and a tone of gray. So you're gonna have kind of a fluidity of the motion there. Instead, a fluidity of the motion there. Here, guys. You're gonna have gray, light gray, gray, and gray, dark gray for the formality. And this is the x-axis. You're gonna have system. This is not to control so system, but the system, any kind of ambiguity sounds like typo that comes with slang system can go from the slang system, and that's what I work. So we're gonna work on type reduction engine. So let me try to model this properly. So how does K and cluster work? So let's do the sentence behind me again. I will be back at 3:15 p.m. So that's basically classified as a two colorable. I'll be back. I'll be at nationwide at 3:15 p.m. That's an independent sentence. So this is one. This is an independent sentence. Independent. Let's start with dependent sentence. So the person will be. I'll be back. I'll be at the road. This one people at CISCO at 3:30 p.m. Well, so at CISCO at 3:30 p.m. At CISCO at 3:30 p.m. Is one sentence now. This sentence has two columns. What will happen? So can either resolve to an order or chaos? Like is there order in the system or is there chaos? There's chaos here. So at CISCO at 3:30. So 3:30 p.m. So the session at 3:30 is gonna be this is gonna have two chaos. This is be chaos. I mean there's chaos here. At CISCO at 3:30 p.m. This is basically handled by the Lexa. Now, because there's chaos in the system, this goes to Lexa. Lexica. And Lexa will say, oh yes, this is basically a dependent sentence. A dependent sentence. So it goes to chaos. So I just go after it's a dependent clause. And what's the question? It doesn't give you a full picture. Cannot use it. Can only one as a pictogram. It cannot be one as a pictogram. It is not a pictogram. You cannot create a picture of this at test call at 3:30 p.m. What will happen at this at 3:30 p.m.? Yes, that's one dependent sentence. Dependent something. It's an incomplete sentence. It's an incomplete sentence. So please go to Alexa for interpretation. For more information. So this basically, and then you go to at the word at and back of the word. Now back of the word at back of the word on back on word back on the word at 4:45 p.m. will be back on the word at 4:45 p.m. will be back on the word at 4:45 p.m. will be a part of it will be back on the word on 4:45 p.m. will be back on the word. So this would be back on the ward at 4:45 p.m. Because it's not I'll be back on the ward. So this is another dependence. So you have two dependencies. You're gonna have colors. You're gonna have two colors. So you're gonna have two shades of so for this is resolved. You're gonna be at Tesco at 3:30 p.m. Back in the world will have colors. So this will have a bipadded color system. So basically, if you want to cluster them, there'll be a cluster, two separate clusters, two dependent clusters. So there'll be two dependent clusters. Two different clusters with different semantics, different semantic meaning. So this one part of some. There were two dependent clusters as I'm saying. Between two lexicons. So the two lexicons will be so if you have a context of lexa, is it a lexa? Yeah, they will have those share two lexical meanings. Two meanings because they can so that'll be two will be the two lexicon and that'll be the lexicon, that'll be the meaning of the system. And the probe of the state P given external X given X will give. So they have two isotropic states, and that's less isomorphic and tropical, meaning they share different isomorphic relation because they are topological. So tropic means they are topological. Two topological states of dependent clauses but different meanings, different meanings. And that's the difference between two clusters, the difference between two lesser clusters, and one parser structure. So they have two weapons. So they have, so they say the color of this would be a factual. This would be a factual information. This would be a factual. This would be informal, factual, informal. Is it formal? Factual, formal. Yeah, factual, formal. So the factual, formal, and static. Factual, formal, static language. So this is a factual, formal, static language. So, because it's the character of Lexan parser, so but CISCO means is the bottom of parser, so and you're gonna have the last one. The last one will be I can't do this formally, guys, but I already marked already. Tesco at I'll be back at Tesco, and you're gonna have to all mapping to one dependent clause. One dependent clause. Via consensus, one dependent one clause. I'll be back at Tesco at I'll be at Tesco at I'll be at Nationwide at 3:30. I'll be at Nationwide at 3:15 a.m. p.m. So that's the model there. So I really kind of drag up with language there. But let's go. So the goal is to have kind of formality bleed not bleed out, but factual map between the simple language model, which is again via topological resolution, which goes a DAG. So whether you see the data, whether the system outputs its own data, you can also know the state of the system, whether it's a command or not. What made the mistakes are the transparency in the ES system I'm building. So thank you guys for watching this video. I hope I can formalize this properly. But that's the pro system. So you're gonna have the equation of v squared minus 4ac. Resolve this via consensus, which is minus 0 less than equal to 0, which is minus 1, equal to 0, which is no. But it was this was consensus which has been coded. So one more thing. So you have the y equals minus b squared minus b plus or minus square root of b squared minus 4ac over 2a. So if you have the y, the growth of the axis of y, this is of the axis of the fraction of the formal and informality, via bipolar solution, and it grows like a spring, the b squared minus 4ac, b squared minus 4ac determines if the change in y given b is greater than or equal to 0, changing y given b is greater than or equal to 0, then you have a consensual one, and this consensual one will mean there's a system, that resolve the states. So if it's factual formal, if it becomes 1, then it goes formal. So this is a formal language, or formal language, or formal language. Formal is very fine. You get system as a big matter. You have fictional, they have factual. So formal, informal, you have fiction, you have factual. This is formal, and you have dynamic involving. And this is the quantifiers of the tripolar nature. So if you have b is less than or equal to 0, you have the opposite one. So you have b is less than or equal to 0. So this is b so change y equals b would be informal. No, will be fictional, like a story writing, informal, like my writing, my typing, and static languages. It's a stack language. So you're gonna have the system here, and you're gonna have the b is more than equal to 0, which just means it's a static system. It's a static system. So in a static system, it's just static, and we have consensus. We have everything we need to continue. It's just okay with that. It just made the baseline, and the baseline is basically less than equal to 0 metric. Thank you guys for watching the video.